After 11 years of its existence, I discovered the underwater farm on the shores of Italy. It's called Nemo's Garden, and you are probably wondering, how? Great question. So we have these 6 sexy greenhouse-like domes around the center of the farm. They are located 5 to 10 meters below water, some 100 meters into the sea. This provides the plants with almost absolute isolation from all the harsh conditions of land-based agriculture. The water holds a pretty constant temperature so they can't freeze. It also keeps all the pesky pests away, and an underwater farm can't be hit by a hailstorm. Also, in this depth, the light seems to reach just fine, and the company even says that thanks to the air in the domes being pressurized, the plants grow faster and are more packed with nutrients than their land-based buddies. The farm grows herbs and veggies, mainly basil, at least that's what they advertise, hydroponically. They use a 10 feet long tubing that houses some 60 plant pots in each dome. So far so good. The main objective, as portrayed by the father and son behind this endeavor, is to research new ways of agriculture to feed the growing population. Since they are both avid scuba divers, it occurred to the father one day that instead of using up the scarce arable land, farmers could maybe utilize the other 70% of the planet to grow food for humanity. So he, along with his son, invested some 100,000 euros of their own money into this project and actually grew some tomatoes and basil under the sea. From my point of view, that's impressive. So now comes the fun part where I explain why this project likely doesn't have no meaningful future. I know, they are just trying their best to innovate, and that's good, but hear me out. The founders would like this project to be the solution for the global food crisis that's incoming, which I deem unnecessary, and I explain why in my food waste video. And they also claim that Nemo's Garden is very sustainable, so let's hear the facts. According to the company, the whole thing is almost exclusively powered by green energy from their solar panels and a windmill. Okay. The plants are housed in the submerged domes anchored to the seafloor. Water is supplied by naturally occurring evaporation inside the domes. The salty water evaporates and hence desalinates thanks to the differences in the temperatures between the water and the air inside. It then condenses on the dome wall and is channeled into the hydroponic system. Alright. Also, there is no need for pesticides since it's fairly hard for the pests to attack the plants. True. This leaves us with only 2 inputs that the farmers have to provide for the plants to grow: electricity and nutrients. We've already touched on the electricity, so now the nutrients. They don't really say what they are using, but according to Nemo's Garden website, they want to make the nutrient solution using only algae in the future, which I guess is responsible considering the environment. As I was discovering all these nice facts, I came to quite like the project. So I asked myself, how could this be scaled in this responsible fashion? I thought really hard about this, and the answer is no! They say they would like to utilize the other 70% of the Earth. There are a few small problems with that. Plants in general need red light to grow properly. Water doesn't like to let red light through. That's why even in a perfectly clean water there is virtually no red light at the depth of just 15 meters. The company knows that, and that's why their domes are located at the shallow depth of 5 to 10 meters. If you think about the oceans, spots just 10 meters deep are a pretty rare occurrence. In fact, the shallow part of the ocean, called the continental shelf, which is already 100 to 200 meters deep, makes up just 7% of the oceans. The rest is a few kilometers deep on average. That being said, we could still use the rest, but that would need some complicated solutions that I'll talk about later. Another factor, the temperature. Nemo's garden is located in the sunny waters of Italy, and the temperature inside the domes is reaching tropical peaks of 30 to 31 degrees Celsius in July. I would say this would be fairly difficult to replicate, for example in the Norwegian Sea, with annual temperatures averaging at around 10 degrees Celsius. That is, without artificial heating. So this leaves us with only two choices. Either limit the production to a small percentage of shallow, warm waters, grow some high-value medical herbs or something, and hope to one day maybe make a profit, which is very underwhelming, or spike the electricity consumption and reinvestment and engineering challenges by making some monstrous contraption with a questionable business plan and impact on the environment. It would also need to be anchored, but who would wanna dive 2 to 3 kilometers deep to anchor it? Or it would somehow have to float a few meters below the water to retain the benefits of being protected from the outside environment. But making it stay stable at a given depth under the sea level would likely consume mountains of energy, which increases the running costs. So to even be able to dream about making a profit, it would likely have to be a gigantic floating shoebox of sorts with multiple stories, heating, artificial lights, and being farmed by robots, and made most likely from metal to not disturb the surroundings with the artificial lights. This all means an entry investment through the roof! And since we are now talking about the deep ocean, the harvest would have to be collected by boats. Well, as I am now filming this, it now occurs to me that boats do much of the heavy lifting in terms of the global food supply chain. So if the boat left the port, went to the farm on the deep sea, collected the harvest, and then went straight to the destination where the crops are supposed to be offloaded anyways, it may make some sense. But other than that, it still seems too complicated to make economical and other senses. I mean, seriously, if you see a way how to make this idea work and remain environmentally friendly, let me know. I would like to hear it. And also, even if we were to scale the production only on the shallow ocean shelf, it would most likely do some damage to the environment, which I don't believe is the right way to go. On this note, the company says, we've researched our environmental impact. There was nothing present on the ocean floor when we installed the biospheres. Now, it's crawling with life. But they remain aware that if they were to scale, this could likely change for worse. And I still didn't figure out how the plants get enough CO2 because I don't think there is that much coming from the water. I've reached out to the company, but they didn't reply yet, so if they do, I'll write it in the comments. Overall, I view this as a good experiment since it makes people think. But if you are interested in how I would solve world hunger with a more realistic solution, then check out this video. Thanks for watching.